Hello and welcome to our presentation. We are Team 1, the Cyberbots, with Muhammad Abdullah, Wahab Khan, Zaim Siddiqui, Ty Grant, and Bijo Jan. This is our Project 2, where we will show you how we designed a controller for a robot arm that is driven by a closed-loop system. The system requirements include having 0 steady-state error, less than 10% overshoot, and less than 1 second of settling time. Our approach and challenges include obtaining the transfer functions P of S for the plant, including the actuator and pendulum, as well as T of S for the closed-loop transfer function system. Design a controller with 0 steady-state error and transient response. We assume 0 initial conditions, small angle approximation, and 0 inductance. We chose the EC90 flat brushless motor for this project. Our method begins by creating a block diagram, then finding the supporting equations, then solving for the transfer function, and then confirming that our steady-state error is 0. Our block diagram begins with our reference angle as our input, which is then sent to the controller where some error is introduced, where a control signal is sent to the plant, where there is finally an output angle of theta. The output angle then returns to the reference angle input to complete the closed loop system. The closed loop block diagram may then be reduced further by combining the controller and the plant because they are in series. For the supporting equations, we begin by defining the equation for the transfer function for the closed loop system. We then define the transfer function of the plant, which was determined in Project 1, where the equation of motion is also the same. We chose for our controller C to be an integrator, where C is equal to K over S. An integrator style controller will allow our steady-state error to be 0. For the third part of our method, we calculated the transfer function T of S, where we plug in the transfer function of the plant and our controller. After simplifying the calculations, we end up with our transfer function T of S, which is a closed-loop system. And lastly, we calculated the steady-state error using the final value theorem. It was determined that our transfer function settles at a value of 1, which indicates that our steady-state error is 0. To calculate our results, we used the Octave software. We started by defining the variables of our robot arm and our motor, which are the same values that we used in Project 1. The plant transfer function T and the controller C are also defined, and the product of both of them is equal to the open loop transfer function, which may then be converted to a closed loop transfer function by using the feedback function in Octave. With the closed loop transfer function calculated, we may then plot it as a step input by using the step function. We were then able to manually calculate the settling time, the steady-state error, and the overshoot of the system, as well as plotting the transfer function poles. By inspection, it is shown that the steady-state error is essentially 0, and the overshoot is 0.023%. However, our settling time is around 95.5 seconds, which indicates that we failed to meet our settling time goal of less than 1 second. To conclude the design of our controller for a closed-loop system, there's only one free variable K that needs to satisfy 3 constraints: 1 second of settling time, 0 steady-state error, and 10% overshoot. With the current resources available, at least one of these constraints could not have their criterion met. Something to note about our transfer function is that our peak time is undefined, and we failed to meet one of our 3 requirements, which was peak time, at 95.47 seconds. However, we were able to achieve a steady-state error of 0 and an overshoot of less than 10%. In the future, we aim to achieve a controller design that will incorporate more than one free variable that will help satisfy all the given constraints and subsequently all of the 3 customer requirements. For the logistics of this project, Muhammad worked on the presentation and formatting, Zaim worked on the calculations and presentation, Wahab worked on the report and presentation, I worked on the video presentation and editing, and Bijo worked on the report and editing. Thank you for watching our presentation on a controller design for a closed-loop system of a robot arm.